So let's do an example. X minus 7 over x minus 3 is greater than or equal to x over x minus 1. You want to know what are the solutions. What values of x make that inequality true, greater than or equal to? Okay, so note, the first thing I want to do is subtract to get both expressions on the same side of the inequality. Do not multiply or cross multiply that x minus 3 and the x minus 1. The reason is because you don't know whether they're positive or negative. It depends on the value of x, so you don't know whether to switch the greater than or equal to a less than or equal to or not. And you'd have to do a bunch of cases, and it's a mess, so don't do that. Okay, just subtract so that everything's on the same side. That's kind of the trick with these. And then get a common denominator, right? And add them. So you should know how to add fractions. If not, go back and review. Multiply out the numerators so that you can combine like terms between the two terms that you would have in the numerator. That way you get 5 terms in the numerator. The x squareds cancel out. That's kind of nice. I distributed the minus. I didn't want to mess up on the minus sign, especially on the 3x, the minus 3x. So I distributed the minus in its own step. Wrote it over a single denominator. X squared minus x squared is 0. So now I'm just combining like terms. Minus x plus 3 is minus 5x, and then plus 7. Okay, so nothing reduces, but I wouldn't reduce anyway. So I want to know when the numerator is 0 and when the denominator is 0. Numerator 0 will be solid dot for this one because of the equals, right? Because the equals there. And the denominator, when those are 0, they're always open dots because you can't divide by 0. So let's do this one first. I just set the numerator equal to 0. And I did this kind of shortcut. Move a term to the right, it changes signs. Move a term to the... Yep, and that's all I did. So I just like positive numbers. And then just cross multiply the 5, and you get 7/5. Okay. So that's going to be a solid dot. I decided to graph it a little later, so I actually wrote out solid dot to remind myself. Sometimes I'll just draw a solid dot to remind myself. Or I'll just draw the line and then just graph it on there as I go. Set the denominator equal to 0. You get x equals 1 or x equals 3, and these are hollow dots because it's denominator. So now I'm going to graph them. Okay, so 7/5 is 1.4. So it's just easier to graph in that form. And so now this divides the number line into 4 pieces. 1, 2, 3, 4 different regions, 4 different intervals. So I need a test point for each interval. I take the test point and I put it into, probably the safest thing is to put it into the original and see if that holds or not. And check them off if they do, and either cross them off or I write no if they don't. And then shade in the regions where it works, where the inequality holds. So I'm going to pick these points. I'll probably use 0, 1.2, 2, and 4. And I'm just picking these points. It can be any point in the intervals, right? And one in each interval. I'm just picking ones that look like they might be easy. So x equals 0. I'm going to do that one first. It's a good idea to write it just like this. X equals 0 colon. So that you're keeping track of what you're doing. So you get... Oh, I decided... Okay, this is risky, but I decided to use this one down here because I can just use the signs of each of them. It's risky because I might have made it... There's a lot of computation here. I might have made a mistake. But actually, it's not so risky if you check your endpoints, and I probably should have. So 1, if you put it in here, well, you're dividing by 1, so that's an open dot, fine. 3, if you put it in here, it's open dot, so that, yeah, fine. So the 1.4 is the one you would want to plug in here, and use your calculator or something and plug it in here and see if they're both equal. They should be equal. So the endpoints are where things are equal, at least this endpoint. And if I check that, then I know these are right. And the only thing that could go wrong is I could have this inequality going the wrong way. So it's a little risky doing it this way, but I did it this way anyway. The other way to do it would be to take 0 and just plug it in here. You get negative 7 over negative 3, which is 7/3. Is that bigger than negative 1? Yes. So that was actually pretty easy. So that's yes. Right, and you'd have to check that for each of these. You can use your calculator on them if you want, especially with this 1.2, right? But I use this down here where I can just keep track of signs. This down here. So 1.2, that's positive over positive times negative, so that's negative. And I wanted positive, right? Positive. The equals is the endpoint here, so they have to be positive for it to work. So that's no. Then I tried x is 2, negative over positive, that's yes. And I tried x equals 4, and that's a no. Now, these are alternating signs. They don't always alternate signs, so don't assume they do. You have to check all 4 of them. So I shade in the regions that worked, like that, and then I write that out in interval notation, always reading left to right. Left arrow is negative infinity, right? So negative infinity to 1, and 1.4 to 3, and make sure you use a square bracket on the 1.4, because that point's included in the solution set. And that's it. That's an example of solving an inequality, a rational inequality.